So we start with this ladder that's 25 feet long and is leaning against the wall of the house. I highly recommend you draw diagrams for everything. So we have a wall. We have a 25-foot long ladder leaning up against it. Okay. The base of the ladder, which would be down here, we agree with that, is being pulled away from the wall at a rate of 2 feet per second. So we first need variables here. So let's call this H for height. We'll call this B for base. And we'll call this, I'm going to put this 25 on the inside. We'll call this L for ladder. And we already know that that equals 25. So just to keep it consistent, I'm putting all my lengths on the inside. And then I'll put some of my rates of change on the outside. So if the base is being pulled away from the wall at a rate of 2 feet per second, is this length growing or shrinking? Growing. Right, the base is being pulled away. So dB dt is growing. That's just going to give me a positive 2. Okay, so that's changing at a rate of 2 feet per second. So far, so good? What is dL dt? 0, because your ladder is not changing length. Your ladder is a fixed size of 25 feet. So dL dt is going to be 0. And then the question is, how fast is the top of the ladder moving down the wall? So what are we looking for? dH dt is the big question mark. When its base is 7 feet from the wall. So what is that giving us when the base is 7 feet from the wall? B equals 7. Now that B obviously is changing, but at the moment it's 7. So take a look at our three, what were variables, okay? L is really never going to be a variable, but B is constantly changing, but at the moment it's 7. But if we have our variables B, H, and L, what equation brings those three variables together? Correct. H squared plus B squared equals L squared, the Pythagorean theorem. That's the formula that links the variables we're talking about here. So that's the formula we're going to derive. So we have 2h dH dt equals 2b, plus, not equals, sorry, plus 2b dB dt equals 2L dL dt. And we're going to plug in what we know. So, what is our H? What did you say? We don't know it. They didn't give it to us, but we can figure it out. It's like that problem on the homework that was xy equals 8. We don't know what H is exactly because they didn't tell us, but we can figure it out because at the moment that B is 7 and the L is 25, can't we figure out H? Okay? So 7 squared plus H squared equals 25 squared. So at this same moment, we should recognize that Pythagorean triple. Not sure if we do or not. 24, good, Alec. So at that moment, H is 24. dH dt is definitely what we're being asked for, so we don't know that. Plus 2 times our B is 7. Our dB dt is 2. Our L is 25. And dL dt is 0. And we'll solve for dH dt. Okay? So we have 48 dH dt. And I'm going to subtract this whole thing over right now. That's 28, yes? So if I subtract 28 over, this will equal negative 28. Good? Divide both sides by 48, so dH dt equals negative 28 over 48, which is going to reduce, both of those are divisible by 4, negative 7 over 12. What's the unit here?
Per second.
Feet per second. Negative 7/12 of a foot per second. Now that's the value of dH dt. Here's the one thing with related rates problems I'm going to caution you on, especially with multiple choice. Because given the way that they phrased the question, if they had negative 7/12 feet per second as an answer and 7/12 feet per second as an answer, you would actually have to circle the 7/12 because they already kind of used down in the question, right? If they said, what is the value of dH dt, that's it. If they said, at what rate is the height changing, like they just left a blanket statement, at what rate, negative 7/12. But they said, at what rate is it moving down the wall, they've already kind of implied that negative. So it's moving down at a rate of 7/12 of a foot per second. So just be careful of that. Does that make sense? How that can get tricky? Yeah, it's kind of annoying. I would not write a question like that, but it happens on the AP questions that I've seen. Okay? Excuse me? No, the questions that you've been taking on your tests and quizzes are AP questions. Mm-hmm. What did you say? Okay. Part B. Find the rate at which the area of the triangle formed is changing when the base of the ladder is 7. So the good news is they kept the base of the ladder 7. So that's a plus, right? So all this information that we've already found out is still going to hold true down here if we need it, okay? But now they're asking what is the rate at which the area is changing. So what formula should we use and derive here?
1/2 BH.
Area equals 1/2 BH. Perfect. So when I derive this, I have dA dt equals. How about when we take the derivative of the right-hand side here? What do we have to do? Product. We have our first 1/2 b times the derivative of h, which is dH dt, plus our second h times the derivative of the first, which is 1/2 dB dt. And then we're going to plug in what we know, and hopefully we know it all. If not, we're going to have to stop and figure out, well, how can we figure that out? But dA dt is what they're looking for, the rate of change of the area. What's B? 1/2 of 7. What is dH dt? Negative 7/12, so we found it in part 1. Plus, what's H? 24. And 1/2, what's dB dt? Good. So we do have it all. We don't need any side projects here. So I get negative 49 over 24. Plus, these 2's are going to cancel, aren't they? So plus 24. Now what is this as a mixed number?
2 and
24 goes into 49 twice to get you to 48.
2 and
Good. 2 and 1/24 plus 24. So, say that again, Alec?
21 and 23, 24.
Very good. So 24 minus 2 will bring you down to 22. And then you're subtracting an additional 1/24. So it's 21 and 23/24. What's the unit? Yes, feet squared per second. Because it's area, it's square feet. And then because it's the rate of change of the area, it's per second. Good? How are we doing? Good? All right. And then part C with triangles, something else we can be asked. Find the rate at which the angle between the ladder and the wall. So let's go back up. Which one's the angle between the ladder and the wall? Top one. Ladder and the wall. So I'm going to label that theta. At what rate is that changing when the base of the ladder is 7 feet from the wall? So again, we're still dealing with the 7 feet from the wall, so any of this information that we may need is still good. Thank God they haven't changed like the number of feet from the wall where we might have to go back and figure out all of that. So what formula can I use that connects and brings theta into the mix? Aaron?
Sine of theta equals opposite over hypotenuse.
Right, you could do sine, you could do cosine, or you could do tangent, right? It may make sense to include the constant in there, just so you have a 0 that will cancel some stuff out. So sine or cosine is a good idea. So he said sine simply because, let's pretend this was the initial question. If we didn't know these pieces of information over here, we wouldn't have to worry about it. Sine of theta equals opposite B over hypotenuse L. So sine of theta equals B over L. Now again, because L is a constant, and that's not changing, like B, at the moment, we're dealing with when B equals 7, but B does change. The ladder is always 25, so we don't have to use L. We can just do 25. And actually, so we aren't thinking product rule, or quotient rule, because there's really no need to. We can think of that as 1/25 B. So now when we derive, what's the derivative of sine theta? Cosine theta, d theta dt equals the derivative of 1/25 of B is what? Very good, 1/25 dB dt. Perfect. So we're looking for d theta dt. We have dB dt is 2. What are we struggling with here? We don't know the angle measure. And I'll be honest with you, we're not going to find the angle measure. I don't want to find the angle measure so much as I want to find what cosine of the angle equals. And that I do know. Look back at your picture. What is the cosine of theta? It's the adjacent, which we know is what right now? What's the value of h when this is 7? 24. So adjacent of 24 over hypotenuse of 25. So I don't so much care about what theta is. I want to know what cosine of theta is. And the cosine of theta is the adjacent of 24 over the hypotenuse of 25 at this moment when the ladder is 7 feet from the base of the wall. So we're just going to use 24/25 in for the cosine. Do we follow that? And I know it's easy to get wrapped up, like you're trying to plug in for variables, so maybe you're thinking like, let me find theta, which is, I think, is natural, but just now know that we don't really ever care what the angle is, we care what the cosine or the sine or whatever it is of the angle is. Do we follow? Okay? So when we divide both sides by 24/25, aka we multiply by the reciprocal, 25 over 24. On both sides, we get that d theta dt equals, our 25s are going to cancel, and we get 1/12. 1/12, what's the unit? Angles are measured in, I would say radians. Although it doesn't say. I put radians. I think the default is radians. I might have to ask on that and get back to you about the radians, but I think the default is radians, I really do, but questions on that? Does that make sense? So those are all the different, you might be asked something with a Pythagorean theorem, something with an area, something with an angle for those. Does that make sense? So is this angle, as is suggested by the d theta dt value, is this angle growing or shrinking? Growing. Does that make sense to you? If you think about this ladder, maybe a few seconds later, that wouldn't be as high up the wall, but would be further out. So that's shrinking, but that's increasing. Does it look like that angle is getting bigger? Yeah. Okay, so that should make sense that you got a positive. Just something contextually to make sure adds up, you know? Because if you got if you can visualize that and see that d theta dt should be increasing, but yet you get a negative number, now there's a contradiction and you might want to take a second look at your work. Okay? Good? All right. Drawing the picture is going to be one of the harder parts, I got to be honest with you. An airplane is flying at an altitude of 5 miles and passes directly over a radar antenna. Well, this is going to be my radar antenna. And an airplane is flying at an altitude of 5 miles. So here's my airplane. Looks like a bird. And let's say it's going this direction. And this altitude of 5 miles is staying the same, right? So I'll put the size lengths on the inside. A equals 5 for altitude, and A dt is going to be 0, because this altitude is remaining consistent. When the plane is 10 miles away, so that, I'm assuming from the radar, when the plane is 10 miles away, so I'm assuming that distance is 10. The radar detects that the distance is changing at a rate of 240 miles per hour. So d dt, the rate at which this distance is changing, is 240 miles per hour. We're looking for the speed of the plane. In other words, how fast is it flying this way, right? The rate at which the distance between the radar antenna and the plane is not necessarily the speed of the plane. Do we follow? So, at this moment, I'm just going to give this a variable, x. At this moment, what is x? Pythagorean theorem, 5 squared plus x squared equals 10 squared. Subtract 25 from both sides. So x squared equals 75 and x equals root 75 at this moment. And what they're looking for is the speed at which this plane is flying. So dx dt. Okay, so again, the formula that we are going to derive is a squared plus d squared equals x squared. We have 2a dA dt plus 2d dd dt equals 2x dx dt. And then we just plug in what we know. 2 times 5 times 0 plus 2 times 10 times 240.
Shouldn't be 2x equals...
Wait, what'd I do?
Shouldn't it be a squared plus x squared equals b squared?
Thank you for auditing. A squared plus x squared equals, that would have been annoying. It already is annoying. Switch these, 2x dx dt. Sorry. We're back. 2x is root 75. Dx dt is what we're looking for. 2d is 10 and dd dt is 240. So the 0 cancels all that out, which is nice. Root 75 is the same thing as what? 5 root 3. So I can make that 10 root 3, yes? So I can divide both sides by 10 root 3. And dx dt, the 10s will cancel, will be 480 over root 3. If I rationalize, that's going to be 480 root 3 over 3. And 48 divided by 3 is 16, so that'll just be 160 root 3. And that's miles per hour. Okay? Alright, your homework tonight is a worksheet. So I'm going to hand that out. Why don't you do, let's just do 1 through 4 on the worksheet. Okay? 1 through 4. The answers are on the back. Definitely you're doing it on a separate sheet of paper.
I mean, yeah, okay, there's no room.
Yeah, there's literally no.
Okay, so
figure it. So just 1 through 4.
Also, still.
It's kind of interesting, isn't it? Like, it kind of makes sense. It's kind of cool that it actually is useful in the real world.
Yeah.
Maybe that's what I'm getting. I know. Something's good about it. I don't know what it is.